change, the media change, and so it's like if you want to take the full advantage, you have to go prepared to the hiking, but it's definitely worth
Yeah,
doing it.
I'm totally up for that. Thank you.
You may recognize some of them.
Supposed to donate.
Are we ready?
Ready?
Yeah.
Everybody looks ready.
Ready.
Oh, and Bobby's excited too. Well, good evening, everybody. Welcome to Evening with the Experts. Tonight we have, as I've said before, an expert among experts, especially when it comes to very exciting realms of research that are very pertinent to what goes on here in Durham with our fat-tailed dwarf lemur colony, and research into the only primate hibernators. They live in Madagascar, and they're lemurs, which makes them like 5 times more exciting than anything else outside of the lemur world. We have postdoctoral researcher Dr. Marina Blanco here with us this evening, who's going to tell us all about her exciting work in Madagascar with Hibernation species. I'm looking forward to it. I hope that you are as well. We have a fantastic crew tuning in online who I want to let you know the question and answer application is launched. So as the talk goes on, you can type in questions, and then at the end of the discussion, we can pull those up and answer those in the question and answer session. And you guys will actually be able to ask the questions. You don't have to write them down and pass them forward or anything like that. I'll make you do that. But we'll begin. Dr. Blanco.
All right, thank you. Thank you for coming. I am always very thankful when I have an opportunity to introduce people to these fascinating lemurs. Before I started officially the presentation, I wanted to give you a few facts, the first which was just mentioned by here. Dwarf lemurs are the only obligatory hibernators within the primates. There are other lemurs, like the mouse lemurs, which are kind of the cousins of the Carogallius. They are smaller. They may undergo hibernation or daily torpor sometimes. And there are other prosimians. There are non-lemurs, like the galagos, bush babies, living in Africa. Under extreme circumstances, they may undergo torpor. But Carogallius, the dwarf lemurs, are the only primates, all species, all individuals will hibernate under different conditions in Madagascar. So that's very unique. There are several species, and 5 as of now, but this number may increase. The main difference I want to show you is that there are species that are mainly found on the east of Madagascar, and then one species mainly found in western Madagascar. So this is the Carogallius medius. This is a species actually housed here at the Lemur Center, you can see. They're highly specialized in dry, highly seasonal forest. Very hot in the day, very cold at night in the winter time. Whereas the eastern species, Major Crossley and Seabreai, they occupy rainforest environments. From lower altitude lowlands of rainforest to high altitude forest. So there is some variation in terms of what the rainforest look like in eastern Madagascar. But the main thing I wanted to remember is the eastern species are a lot larger than the western species. They are at least twice the size. And this one here, the Seabreai, is one of the species that I have studied, live in sympathy with this Crossley in one of the sites in the high plateau, seems to be a high altitude specialist. So this lemur appears to occupy only high altitude rainforest, which means the coldest of the forests in Madagascar. It has not been found anywhere else. So that's the second fact I wanted to share with you. And the third one might not be very relevant to this presentation, but I just wanted to mention that this family of lemurs, Carogallidae, the family of the small body nocturnal lemurs, including dwarf lemurs, mouse lemurs, giant mouse lemurs, and other ones, actually diverged from other lineages of lemurs relatively recently as 22 million years ago. And yeah, it seems like a long time, but it's recent in Madagascar history. The reason I want to point this out is, and this is just an example, this is a phylogram showing different groupings of have humans here as an outgroup, and then you have the non-lemur prosimians. So the first branching off of the lemurs are the ii, which are very different from any other lemur or any other primate for that matter. And then you get this branching off of your Shifakas, your Propithecus, and the group of the eulemur, the Lemurcata and eulemur species and Maurici species. But it is later on that here the other lineage of sportive lemurs branch off. It is here where the Cerugalius and the Cerugalidae family start diverging, start speciation and diversifying, which means that maybe a lot of the features of these small body lemurs, including hibernation, maybe a derived characteristic, a derived feature, not something that the ancestral lemur stock brought in to Madagascar, which makes hibernation kind of convergent, if you will, compared to other tropical hibernators, not something that was retained from the ancestral condition. And again, although this is not something that I will be really discussing today, I just want you to kind of have in mind that that may be a possibility, because traditionally people think of lemurs are these kind of primitive primates that kind of retain characteristics of the ancestral primates, and some of them may not. They may actually show very derived traits. And it would be very cool if we can show at some point in the future that hibernation actually evolved in Madagascar in this particular group. But I wanted to start this presentation with some sort of a reenactment. Was it about 6 years ago or so, I was in central eastern Madagascar in the high altitude site, Sinjorivu, collecting some data on mouse lemurs. I was finishing my dissertation on reproductive biology of mouse lemurs. But I had to start capturing some dwarf lemurs, which are a lot larger, and I knew they hibernated. To collect opportunistic data. I was not really focusing on them. But I had put some radiocolors in a couple of individuals. And later on, it was early March, I was already back in the US. I contacted a colleague in Madagascar so he could go to the forest and capture these animals with collars and remove the collars because the batteries were going to run out. And I didn't want the animals to keep wearing this. And so my colleague went, captured a couple of animals. One of them, the signal came from the ground, and he thought the collar had fallen off. So they started searching where the signal was coming from, and they started to disturb the soil. And they found that the collar was actually attached to the animal, and the animal was curled up in a ball, cold to the touch, underground. And so when he told me this, I was surprised, and he was surprised, because what I knew about hibernation in lemurs is that they, in Western Madagascar, the smallest species, they hibernate for up to 7 months a year in tree holes. But I didn't know they could hibernate underground. So I started to consult with other researchers, and some of them have heard that local people sometimes doing the cultivation of rice or something else, they had uncovered dwarf lemurs, or some people actually with the sticks, we go and try to find the tenrecs or the lemurs to eat them when they are hibernating, but it was all anecdotal evidence. There was no real publication on this. So this is probably what he saw a few years ago. This video was taken last year in a different site close to Sinjorivu, but a little bit lower elevation in Nabatui, and I will show you in a minute the location of these sites. There is here the receiver, and my colleague is trying to locate exactly where the strongest signal is coming from. You see the soil is pretty soft and spongy. It's not really hard. And this is also early March, so it is kind of the beginning for some of these dwarf lemurs, the beginning of the hibernation season. So when I was at this site, I didn't think that these animals were already hibernating. I had expected they were going to start later on, but this particular animal was. See, it takes some time. It's not easy to find them, even if they have colors on.
But it's still quite hot in early March.
It is hot and it is rainy. It is very rainy. We have uncovered one dwarf lemur in an almost like flooded area, which surprised me. Took him out and it was pretty wet. So yeah.
Really?
Yeah, so I don't know, natural selection may. I don't know if that animal would have reproduced or not, but it was strange. I didn't expect to find such a kind of poor from the human point of view condition for hibernation. But yeah, it's true, it's very hot in March and very rainy. So you see there, it looks a little bit clearer, the soil, and I'm guessing it's because of the heat of the animal being underground. It kind of dry the whole surrounding, and where he is. Because it's very early on, and this individual started hibernating only a few days before we recover him, he will come out right away. You'll see that after he's handled, he will kind of. But still, the temperature of this individual is close to the temperature of the soil. It's very close. So, but he's pretty out of it. And, and grabbing things. So this species, this cross-layer species, is at least 2 times the size of the lemurs here, the Chlorogallus medius here. So this is a 450 gram. And remember that if you ask how heavy these animals are, you have to ask before or after hibernation. They almost double their size before hibernation in order to store enough fat in their tails and body to sustain the period of hibernation. So you go from a 300 gram individual to a 500 gram individual in a few months. They just they get really fat really quickly. So when you think about hibernation, usually when I thought about hibernation before, I think cold and seasonal. Animals kind of try to survive the winter in environments where there is food in the winter and it's just too cold for they have to spend, or they would have to spend a lot of extra energy to keep warm, and in a time where there is no much food there. And there are places kind of like that in Madagascar, the site that I just told you in Jorivo that I've been doing work in the high plateau of Madagascar. And there are some mountain rainforests where it also gets fairly cold in the summer, in the winter time. But there are other places in Madagascar where even in winter, it's not really very cold. A place like Kirindi, this is the West Dry deciduous forest. It's low elevation, it's almost sea level, but you have this weird situation in the winter time where the dry season, I would say, is very, very dry, where it's really, really hot during the day and it's really, really cold during the night. You have these huge fluctuations in temperature. And I experienced that this year. It was my first time at Kirindi. Because you read things, and I read this and I thought, okay, but once you are there, it's really dramatic. At 5 in the morning, it's really cold. You're with the winter jacket, and then a few hours later, you have this heat coming, like a cloud of heat, and then by midday, you have shorts and t-shirts. So it's very dramatic. It's very different from Jorivo. I want to give you a sense that wherever you go in Madagascar, you're going to see a variety of forests. Places like in India are dry, and places like Jorivo are fairly cold. And then you have the lowland rainforest when it's really warm even in the winter. And the seasonality is less marked. You actually have food sources of some sort throughout the year. And then places like Marojejy, where you have in a relatively small area pretty much everything. You have from low altitude rainforest to high altitude forest, to disturb bamboo forest with primary mountain. You have pretty much everything in this mountainous region. And actually here, we started last year to do preliminary trapping and capturing, and we found there are actually 3 species of dwarf lemurs. Supposed to be only 1, but depending on where you sample these animals, in the high elevation you find the same species that you find at Sinjorigu, the high altitude dwarf lemur, and then in a lower elevation you find at least 2 more species. So it's a great place to study Cervogalius and hibernation there. So the bottom line is, hibernation is a great strategy in cold and seasonal, but what happens when these animals are exposed under different circumstances, where maybe it's not very cold and maybe they have food? You are hibernating and you're not reproducing. So you have to think whether it makes sense to hibernate or not in terms of physiology, in terms of life history. Just to make sure that you know what I mean by hibernation, this is just a very general definition. When individuals hibernate, they significantly reduce their metabolic rates and their body temperature for a period longer than 24 hours. And this arbitrary definition kind of distinguishes hibernation from daily torpor. Some individuals will reduce metabolic rates, decrease temperature during the so-called resting phase, but then when they are active, they will go and forage every day. But if you are hibernating, you are out for several days, weeks, months. And this is an oversimplification, but when you reduce your body temperature, your metabolism goes down, your energetic demands are significantly diminished, so you spend less energy to sustain your functions. And so what I'm going to show you is what hibernation looks like in these high altitude dwarf lemurs. And some of the parameters that we collect are standard temperature, body temperature. We look at hibernacular preference and temperature of the hibernacula, oxygen consumption as a way to get metabolic rate, as a proxy for metabolic rates. And look at EEG recording. So look at the characteristics of the electric activity of the brain to try to see what the animals are doing at different stages during the hibernation. And then I'm just going to compare the data from Sinjorigu, from the high altitude dwarf lemur, with data collected from the dry forests of the West to see whether there are similarities or differences and what they may mean if there are differences. So this is kind of a collage of the methods, what we do in the field in Madagascar. And just to point out a couple of people working, I've been here almost 3 years, and since I arrived here, the project kind of exploded in a way, because I've been working by myself with colleagues in Madagascar, but now there is kind of a group of people with interest in hibernation that make things more interesting. So for the last 2 years, Bobby here present and actually his family are helping in data collection. So part of what we do is we trap these animals and we put the collars on. These collars have temperature sensors, and this sensor will collect, record I should say, the temperature of the skin every hour. And remember, when the animal is hibernating, it's curled up in a ball, really. So the collar is in touch and tightly in touch with the neck area. And that skin temperature is fairly representative of body temperature, and you will see what it looks like in a minute. So then we collect samples and take measurements and mark them. And then one of the things is to insert these small needles under the skin in their heads to record brain activity. And once they have these colorful cables, they go into sort of artificial hibernacles. These are containers where we put the lemurs back, so other parameters like oxygen consumption can be measured. These hibernacula is attached to these boxes here that will suck oxygen, and then you can measure how much is being consumed by the lemur when they hibernate or when they are active and things like that. And then we try to put these lemur with collar with electrodes, go back to the box, and then attach to the ox box here, and try to put those containers back where the lemurs came from. I mean, this is sort of a disturbance for them, obviously, but we kind of try to minimize as much as possible. And so we leave the individuals in the forest, but protected and covered. And then some data are being recorded and monitored. These animals are monitored frequently when they're being studied in Madagascar. So other people working is Andrew Crystal is kind of the leader in the EEG aspect of the project. He's the director of the sleep research lab here too. Katrin Dausman, a German professor, she did her dissertation on dwarf lemur hibernation in the West, so she's kind of the expert on your fat tails. And then Peter Kloffer, he's kind of getting everybody together and having kind of the ideas of this kind of things that we can address working with lemurs in Madagascar and here at the Lemur Center. So this is just to show you, these animals hibernate underground, but even when you look at where they hibernate, there may be some differences that may be worth studying in the future. Some of them are in this kind of clay-like soil that's very hard, and I'm not sure how the oxygen transfer occurs here. It's very different kind of soil material. Some of them do this. Some kind of go in your traditional spongy superficial area, and then some of them, they may actually, you cannot really tell here, but they're kind of on a slope, and this is very thin kind of soil, but they are on a kind of almost 45-degree angle. So there are some variations, and I don't know, this animal, the other one that one of the ones that we recovered was this kind of flat environment. So the selection of the location is not intuitive. You have to understand what's going on. When they go in a tree hole, you may look at insulation properties of the tree hole or height of the tree hole for security or anti-predator. But for the soil, I just don't know what they're looking for. So these colors give you this information. So they are recording 24 recordings per day. And what you see here is, and these are months from March to September here. You see these animals when this goes down, this is, if we were to match the temperature of the soil, it would be pretty much the same. They're going down in temperature when they hibernate. And they continue to do so, and you see the distance between these peaks here vary, and they get a lot more space in the middle of the core of the hibernation season. At the beginning, it's only maybe a day or two, but they have a space. And why is that? Maybe some sort of internal kind of clock that is regulating that, maybe temperature, it's not clear. But so this is called the hibernation bout. This is when the animal is pretty much at the temperature of the environment, metabolism is very low. And then you get these peaks, and these peaks are arousals. And here is what you would see in an Arctic ground squirrel. This is very small, I apologize, I might not be able to see. But what I want to show is pretty much the same. Individuals that are hibernating at low temperature, and by low I mean below 30 degrees for sure, they must arouse at a specific time. I mean, it's again not clear why. In some cases it takes 10 days, 11, 12, and in some cases 2, but they must arouse. Arousals are indispensable for hibernators, which means that they have to use their fat store, their energy, to heat up to the temperature they would be when they are not hibernating, because they're obviously some physiological functions that need to be maintained at certain times, and those physiological functions need high temperature or regular euthermic temperature. So this is what you see in the dwarf lemurs at Centuribu, all of them. It may differ in how long they hibernate. It could be, this is a 7-month hibernation period. This individual didn't move from the end of February until the end of September from the same underground location. When they arouse like this, they're not necessarily moving or changing anything. They may just stay in the same spot, just heat up for a day, and then the temperature will slowly go down to where they were, the immediate environment. So this is what hibernation looks like in a high altitude dwarf lemur, like you would see in a ground squirrel. In terms of metabolism, so you are taking oxygen consumption here, and these numbers, they are not going to mean anything to you. This is a standard measure of milliliters of oxygen per hour. What I want to show you here is that when an animal is not hibernating and is kind of active, by active I mean awake and walking around. Again, these animals are in containers, so here they are not eating or running, but they are awake. There is this amount of oxygen, okay? So it's about 500 milliliters of oxygen. And this is dark because this is a night, and they are nocturnal, and so they are active in the night. And then, as you know, it's the middle of the day, they will rest, they will sleep, so the oxygen consumption will kind of go down accordingly. When the animal is hibernating and then it starts to arouse, remember the soil may be at 15 Celsius, so it's very cold. They have to go to 37, and they have to produce that heat endogenously. So the oxygen will peak. They will go up to 900 or 1,000 milliliters of oxygen per hour during arousal. But if you count how much oxygen is being consumed during a hibernation bout, it's almost zero. There's nothing going on here. It's 10, 15 milliliters of oxygen. So really, metabolism is down significantly, almost to nothing. And this pattern, when you start comparing temperature with metabolic rates and then what the brain is doing, when the animal is in the hibernation bout, when metabolism is down, the brain activity shows almost like a flat line. I mean, really, it's nothing. The firing of neurons is almost zero. This needle here is close to the back, is kind of picking up the electric activity coming from the heart. And so this is a 30-second epoch here. What it shows is that in a minute, this animal's heart is beating 6 times, and it can go down up to 4 times. And so when metabolism is down, it's down. Most of the time you get things like this, so it's not all perfect. The animal doesn't have to move too much, and you get a lot of distortion in the recordings, but sometimes you get good data. So when the animal starts to rouse, it starts to heat up, you start seeing things like this. This is the heart, representative of the heart rate, and so from 3 in the other one, we have here over 80 or so. So this is not as fast as it's going to get, but you see it's picking up, and there is activity here. So to kind of just sum up what I just showed you, when a dwarf lemur, a high altitude dwarf lemur, is not hibernating, will breathe about 50 times per minute. When it's hibernating, it might not breathe for up to 12 minutes, and then it might breathe 5 times, and then again for 10, 12 minutes, nothing. From a 300 beats per minute in their heart, when they are hibernating, can go down to 4 or 6. From a temperature of 37, is euthermic, is when they are not hibernating, just like us. But it can go as low as 9, and even lower than that in the West. So this will depend on where the animal is hibernating. If the hibernaculum is cold, 5 degrees, the animal will go down to 5 degrees. If it's 15 degrees, it will go to 15. It will just approximate the temperature of the environment. And this is just a measure of calories. So when an animal is not hibernating, it will spend about 120 kilojoules per day. And when it's hibernating, down to 13, which means that in a 7-month period of hibernation, this animal is spending 15% of the energy that they spend the rest of the year when they are not hibernating, which is comparable to temperate hibernators. So, but it's not that easy. I just show you an example of one particular lemur, actually 2 species, but at one side, which is the coldest side in Madagascar. In other places, there are some variations on this theme. So this is the fat-tailed Carogalius medius from the west. Again, the species that you can see here at the DLC, and they sleep in, they hibernate, in tree holes. If an animal is hibernating in a small tree with no insulation, pretty much, the tree hole gets really hot during the day when it's hot, and it gets cold when the temperatures go down during the night. The animal will be doing the same thing while hibernating. So the black line is the body temperature, and the gray is the tree hole temperature. And you see, we go from like maybe 15 degrees or 10 during the night up to 30, 35. It's just tracking. It's going down. It's heating up and cooling down as the day gets hot and cold. These animals can do this for months at a time. They don't need to arouse. They are passively reaching high temperature. They're not producing the heat to go up. They are just warming up and cooling down. If the same individual moved to a large tree where the temperature inside the tree hole doesn't change much, it will show what happens in the high altitude roughly, where it will just stay as the tree hole temperature maintains, and then eventually they have to rouse. They have to reach that high temperature. Okay. What happened with metabolism here? Is this the same case? Ambient temperature, body temperature goes up and down, goes up and down. Metabolism goes up when it's hot and goes down when it's cold. When you look at brain activity in dwarf lemurs hibernating in highly fluctuating conditions like this, when the individual is cold during the night, the brain activity is a slow amplitude kind of voltage, where it's almost like a flat line. When the animal passively warms up, there is some evidence of a sleep, REM-like sleep here. Only when the animal is surpassing some sort of threshold of temperature during the hottest part of the day, and then as it cools down passively, brain activity goes down, metabolism goes down, heart rate, everything goes down. In the case of the high altitude dwarf lemur, this is kind of similar in that this is the body temperature, and the green is the hibernacular temperature. You can see the same thing. There is nothing going on here when it's cold, and then they arouse, metabolism goes up, the blue stuff. And then these lines here are evidence of a sleep pattern here, REM sleep and non-REM sleep. So you compare here, it's the same figure, low amplitude EEG, low metabolism. It's only during the arousal where you start to see evidence of sleep. The difference between these and these is that, remember, these animals are warming up passively. They're not producing heat. They're not using their own energy to go up and down. They're just tracking ambient. These animals here are actually endogenously producing heat to reach the high temperature because the environment where they're hibernating is cold. And so, as you can see, there are some kind of physiological differences even if you have the same animal and you put it in different environments, that animal may react differently, may respond differently, and show different hibernation patterns. And on top of that, you have to take into consideration that these different species of lemur are different sizes, and the energetic requirements change with our body mass. So there are some kind of complications when you try to study hibernation in different habitats, but that's the interesting part of it. This is just temperature. These are Syndraoribulus, like high altitude. These are the two species. This is the smaller high altitude specialist, and the other one is larger than this, and this species also occupies many forests. This is the same time of the year, is mid-March, mid-May. This animal is already in the core of the hibernation season, is going for several days in a row before he's arousing. This individual, however, is hibernating only a couple of days and then arousing, and then a couple of days and then arousing. The temperatures of the hibernacula are not very different. They are only a few meters away. And this individual, this is a different species. This is Carolarius major. This is the largest of the dwarf lemurs. This is over ½ a kilo. And this is from Marojejy, from the north of northeastern Madagascar, in a habitat that is lower in altitude elevation, but still is 600 meters, so it's not low altitude, it's kind of intermediate mountain. The same time of the year, this individual is active several days, and then it goes down hibernation a couple of days and arousing, and on top of that, this animal is in a tree hole. So before was Western dwarf lemurs hibernate in tree holes, Eastern dwarf lemurs hibernate underground. Well, some Eastern dwarf lemurs, they also hibernate in tree holes if it is hot enough, but that needs to be further investigated. So if somebody asks you, when do dwarf lemurs hibernate? To give specific dates is tricky. It's very hard. You can guesstimate that it's going to be sometime during the short day photo period. This is the long days. This is November, December. This is when reproduction happens. They are mating sometime October, November, having offspring in December, January, and then winning their offspring sometime in February, March. So you would expect hibernation occurring afterwards. Obviously, they need some time to store fat. This is the rainy season here. June, July, August are the coldest months of the year, so you would expect hibernation occurring during the cold times, where you would expect also less availability of food sources. But then you have something like this individual hibernating from, as I mentioned, the end of February to the end of September. And in the same site, we had one individual hibernating from mid-August to mid-October. What I know about this individual hibernating in such a short period, she was an adult female, and she had a juvenile offspring fairly young in April. And it was not weaned until I would expect a month or so later, and she was very skinny, and probably it took her quite a bit of time to get fat, particularly because she weaned the offspring when already resources were kind of scarce. So it's not just measuring temperature, rainfall, food availability, but the condition, reproductive condition of the individuals, the age of the individual, the sex of the individual, all these things may play a role in determining the timing and duration of hibernation. So what we would like to continue to do in the next year, hopefully, is to kind of improve a few things. We're hoping to build some sort of more naturalistic hibernaculum, some sort of container that will allow the lemurs to feel more at home and be able to fall, back into hibernation faster and quicker. So if you have an idea, so you think somebody may be interested in developing some sort of artificial soil material that you can put in small container, we are going to be thinking about that. In addition to temperature, to oxygen, we also would like to start measuring other parameters. Maybe with a small collections of blood, we can try to figure out what is happening hormonally and endocrinologically in these individuals. There are hormones identified to be related to metabolism, and we are hoping to get into that. In addition to the parameters that we are already collecting, I want to go to the warmest place in Madagascar and study hibernation there to see what these animals are doing. Going back to what I mentioned before, if it's not really cold and if food is out there, do these animals need to hibernate? Would they hibernate? And if so, under which conditions? This is unknown. And we will continue to try to improve our ways to collect data and bring to new technologies and new techniques and methods, but try to keep it as minimally invasive as possible. If you look at the literature in hibernation, in non-lemur hibernation, there is a lot that is being studied and known in terms of molecular basis and what the tissues are doing and the systems are doing, but there is a lot of invasive stuff going on that we're not going to do. So we're going to try to find ways to collect data, but keep these animals safe. And I want to finish this presentation actually with, this is a picture of Jonas. This is a 29-year-old dwarf lemur. It's probably, he's still active somewhere, a few meters from here. Oh, he's here. He's the oldest dwarf lemur ever. So it's probably a world record that won't be broken anytime soon. I mean, imagine for an animal living 25 years old, it's, if you look at the correlation between body mass and longevity, it will have to be almost a kilo to compare, because animals this small, they don't live as long. But there is a correlation between hibernation and longevity. So we wouldn't be able to know about these things and about aging and senescence if there was no place where they can keep these animals away from predators and from other risks that they find in the wild, to be able to address these questions. So a place like here, it allows you to conduct research and study things that you cannot study in the field. You will never find a 20-year-old dwarf lemur in the field because obvious reasons it would be gone. So this is actually kind of an homage to Jonas and to the Lemur Center for having Kerogalius here, and that will kind of allow to study hibernation in ways that we cannot quite yet study in the field. And so if you have questions, many people have worked with me over the years and funding from different sources, but just let me know if there is any question. This is my email address in case you want to contact me, of course.
Can we go back to asking the question of fat-tailed dwarf hibernate, but mouse lemurs hibernate too?
Yeah, some of
Now,
them.
my understanding was that a female mouse lemur will hibernate 178 days.
Okay, so that's very specific. That probably comes from some paper. This is what happens, but as far as I know, mouse lemurs also come in different sizes, and
Okay.
they are all over the place. Some mouse lemur species, they do get fat in some individuals within populations. So they have been studied, for example, in Kirindi, the same place where the fat-tailed Microceros murinus species living there. Most of the females actually they apparently hibernate because they cannot be captured or trapped. And when they put collars on, they remain in the same place. I'm not aware of temperature or metabolic data from Kirindi, but from southeast Madagascar, if I get the map, there is at least, there are two places that I know of. They had studies on mouse lemurs. The southernmost point in Cinnamontana, which is a spiny forest, that's Microcebus griseorufus, and females there, sometimes they hibernate for several days, and they would have the same pattern as, here, we'll do it faster. What I'm looking for. See if I can go this way. So the kind of hibernation that I'm aware of in mouse lemurs is like the Kirindi one, which is this. A mouse lemur in a nest or a tree hole will go up and down for several days in a row. I don't know, say 100, maybe. And so if they do this, they don't need to rouse. It's kind of the same situation where they would go up and down. I'm not aware of mouse lemurs doing this yet, going into a place where they are kept cold and they are arousing. So all the kind of the hibernation types, which is again south and southeast sun. So you have a population, you have 50 males, 50 females, maybe 2 females and 1 male may do this. The rest of the population, they will remain active. Sometimes you will see mouse lemur maybe doing this for a few days and then remain active or go. And so it's complicated. If you want to study hibernation in mouse lemur, it's a lot more complicated than studying Carogalius because you have a lot of different things going on there. But they do get fat, and that's the critical thing. You cannot hibernate if you don't have a fat tail because you need to live off your tail one day. So some mouse lemurs, even at Sinjuribu, they have these very heavy tails. So I'm expecting them to hibernate, and maybe they do this. So that remains to be studied as well. Yes.
So how many fat-tailed dwarf lemurs have you actually put in hibernacula?
In those artificial.
Yeah.
Total mixed species and everything, maybe around 15. Maybe some of them don't go back to hibernation when you put it back. I mean, obviously it's not what they were doing, so they don't feel maybe as comfortable. So there are many individuals that we try, and after a few days, if they're not going back to hibernation, we take them out and we put them back in the soil because we don't want them to spend all the energy like the days that we are studying them and then they have nothing left for. But yeah, about maybe around 15 or so. And good data from maybe 8, 9, 10. Yeah. But we need a better hibernaculum, for sure.
Don't come to the lemur center.
Yeah.
Would you expect, I mean, the Carogalias that have been here over the years have not gone into a hibernation. Would you expect that for captive individuals like that, for that to have some sort of physiological impact? Whereas in the wild, they would be going through hibernation every year, and in captivity, they're not.
There is one way to know. If you put an animal here, the same conditions as they are in Kirindi, with very hot and then very cold. I'm not aware, maybe I'm wrong, that the dwarf lemurs here, they were not exposed to very, very low temperatures. And I don't know if, because there are two aspects to it, the temperature aspect and then the fattening aspect. The animals, in order to hibernate, again, they have to put a lot of fat on. So I don't know if they are allowed here to get fat enough so they can undergo hibernation. And this is a tricky issue. I know, Bobby, yet in the past, I've known from all captive, publication, these animals were being fed the same during the year, and so they were like getting obese very quickly, and they were having all sorts of issues because in the wild they are not supposed to get the same amount of food. So it's kind of hard to kind of see how much you can give them so they can put a lot of fat on, hibernate, but then not to the point where it could be so detrimental to their health. So I'm guessing with the right diet and the temperature situation as naturalistic as possible, these animals may be able to do the same thing, even if they've been in captivity for a long time, but there is no way to know.
Well, a related question, what would you expect? I mean, the wild Caragaleos are going through this period of hibernations, these, in some cases, really long periods of metabolic slowdown. Whereas you have the captive animals that they're not slowing down. I mean, would you expect that to have a physiological impact on how long they could live or something like that?
That's something that with Sarah Thayer and I work on a paper that hopefully it will come out sometime. It's called Striking Longevity in a Primate. So we're trying to explore the correlation between hibernation and longevity, and we're looking at the records from here. And that's a question that we had and we have. These animals are living a lot like you would expect on a regular hibernator, even though they are not expressing hibernation to the same degree, but they're living a lot longer. So
they already seem to live quite long.
a lot, yeah. Yeah.
But their metabolism also has not been thoroughly studied in captivity, but we're getting there. But the other thing is that their food intake drops dramatically seasonally.
In captivity.
In captivity. So they're not going through full-blown hibernation, but they definitely reduce their metabolic needs on an annual basis, no matter how bad the conditions are that we're keeping them in.
Right.
So
and caloric restriction also seems to have this correlation, I guess, with longevity. So yeah. So in other words, these animals are not experiencing the same kind of hibernation, but they're still showing in terms of longevity and senescent patterns that you would expect in a naturally hibernating dwarf lemur, which is very good, I guess, to be able to have that information from captivity. Something that is being explored now is mouse lemurs and dwarf lemurs. They are showing when they are old enough, these kind of neurodegenerative syndromes that are associated to what Alzheimer's looks like in humans. And so there is a lot of interest on that side. There are changes in brain structure in dwarf lemurs that could cause, in humans, could cause disease, but in dwarf lemurs is reversible. During hibernation, after hibernation, they go back to. There are so many things that are kind of strange about these animals. They become insulin resistant before they go into hibernation. They are taking on this sugar and stuff, and they are not diabetic. They don't have any issues. But then they, of course, they lose everything during the hibernation time. So they have these cycles where they get extreme in one and then they're gonna go back on the other side. So it's interesting to look at metabolism and see what is going on, how you can turn on both things that if you keep them on too long, maybe really detrimental. But if you make adjustment, well, I don't want to be the one making the adjustments, but it's an interesting field because they are so strange to other primates.
Can I ask, in Madagascar, during hibernation, would a group be in the same area, like mom and offspring? Would you find them right next to each other, basically?
I really like to find out that, and I was wondering, so I was excited to get the color from like the units. So during the active season, when they're not hibernating in the high altitude place, they go into tree holes or nests. So usually you see the female and the male, and then the offspring. Sometimes they kind of go their ways, so you find one individual here and one there. So it's not like the typical monogamous pair. Sometimes they tend to, you identify family groups. When they hibernate, I found the two options. I found the adult female, the adult male, and the offspring in a kind of 5-meter area. In other cases, I found the adult female, the adult male really far away, and the offspring the other way. In some cases, the place where they're hibernating is within what is called the home range, the area that they use when they're not hibernating. They are feeding on and moving about. In some cases, particularly males, they may actually hibernate far away outside the home range that they use when they're active. So I don't see the pattern yet. I kind of see the different, all the different possibilities, which makes it hard.
I was wondering about the times of arousal. What happens? Why do they get that spike, and what do they do? And what does it mean by that? Does it mean just a muscle twitch, or does it mean they get up and move around, or what?
So what they do when they arouse, again, why they do it? Something has to happen, and they need to be hot in order for, could it be, and so one of the hypotheses is that, nothing is going on here, so they may be building on some deficits physiologically, be that sleep debt, so they may have to come out to actually sleep during arousal. They may come out because the immune system is completely shut down and to prevent infection and potential other health issues. So there are things happening when they arouse. What is triggering that arousal is not clear. They don't need to move, really. The individual that I show the temperature profile is the end of February to the end of September, the same spot. And she aroused about 21 times during that 7-month period. She stayed in a ball underground. So what happens is that I didn't have a camera there, but I'm guessing that they are just, at some point, they start heating up. From the whatever temperature the soil is 15 degrees, they start heating up. And it takes about 8, 9 hours, 10 hours to get from 15 to 37. And they remain in that temperature for about a day, and then they go down. I suspect that they don't move because sometimes when you uncover these Carogallias from the underground, the layer of soil around the animal is kind of dry and hard. What you would expect when you expose that soil to heat, and then you go back to whatever temperature. So they don't really need to move much, but something is happening inside, for sure.
Mm-hmm. And I'm also curious about predators, because they don't seem that well hidden.
Oh, we
Or,
spend
I guess,
hours trying to find these animals.
Really?
Yeah, we don't have it.
Well, I get like in the tree holes and
Oh, the tree
so I don't
holes.
know it just seemed like they're a bit prone to predators.
Yeah. So the tricky thing is, if you find a hibernating animal in a tree hole, yes, then they're gone because they are not able to react quickly. So if the predator finds the hibernating, the animal is gone. But to find it, I don't know in the tree holes in the west, I'm guessing, there is some sort of selective, placement of going up, or they are actually being predated by snakes, mainly on the west.
Oh.
The underground dwarf lemurs, though, I think their survival rate is a lot higher when they hibernate than when they are active. And actually, for many other non-lemur mammals hibernating, the hibernation, the survival rate is a lot higher. So I would guess that being underground, it's pretty safe for them. I guess. I don't know.
They're like 18 inches under.
Oh,
I mean, they're not
really?
just
Wow.
barely under.
They are
can be 8
between, not inches, but 10, 40 centimeters, something like from this down to here.
Wow. Okay.
Do they dig down there? They don't really look like they're well designed.
They are pushing, their hands look just like our hands.
Yeah.
So I'm guessing they're really pushing their way down. And that's why, it's a simplistic explanation. In the West, they go into tree holes. So you would think, well, if being underground is such a good idea because it's insulated, why don't they go underground? In the West, it's like very hard soil. It's so dry. It just, you try and, I try and it didn't work for me anyways to like make it, hole in the ground. The soil here is pretty spongy. I show examples of kind of clay-like, and so it's not always that way. And what happens sometimes, they use already small cavities close to tree roots, and they kind of go that way and keep pushing. Again, I haven't seen an animal doing this, but I'm just guessing where I found that they may have come from a cavity around, or if they push their way in, it was in a kind of soil that allowed kind of going down. And once they are there and they're gonna go down the route, it kind of becomes this bubble.
So if you were going to hibernate a human for
Yes.
7 months, or if, like, I'm a nurse and I've worked in hospitals, and if you have somebody who's unconscious for a long period of time, you have to do exercises to keep muscles and ligaments from becoming contorted from the positions, right, or contracted, right? So how do they not do that?
Oh,
If they're in a ball for 7 months,
that's complicated. A lot of the work has been done on bears, but bears are a completely different kind of hibernator. Bears actually don't reduce body temperature too much. They remain at 30 or more, so they don't go through this arousal thing. But the metabolism goes down. So this is kind of strain dissociation. Usually in this it's like easier to explain because metabolism goes down, temperature goes down, and everything goes down. But in bears, so there are molecular mechanisms in with the osteoclasts and the osteoblast, all this stuff going on here that somehow works out for them to maintain the level of calcium so that the bone doesn't get too weak, but doesn't regrow. And always try to think about what we learn about these lemurs because they are primates and we are primates can be applicable in the future. There are a lot of things that need to be figured out in order to really have the whole story, because it's not just slowing down metabolism, it's making kind of the heart, the bone and all these things kind of work in unison. It happens, and it's been studied because it's not clear how exactly these animals are not defecating, are not urinating, not for extended periods. So things usually, atrophy and stuff, but it doesn't happen. So all to say, I have no idea.
Yeah.
It's difficult, yeah.
So once an infant is born, it's sort of innate that, because obviously we're talking a short time period here, relatively speaking, between when they're weaned up, gestation ends, and innate they know to store fat. To store fat, But do they necessarily grow during that time period of hibernation, or is it pretty stagnant, and then when they come out of it, then, you know, they start growing?
Yeah, no, that's exactly the case, and that's very interesting because, for example, here in captivity, when you know you are you're given, you know, the offspring is eating and they are not having the extreme kind of conditions in the wild, these juveniles are growing kind of at a regular pace. But if you look at a dwarf lemur, when I first studied dwarf lemurs at Sinjuribu, I was doing a lot of the morphometric part, like taking measurements and stuff and looking at dentition. And the juveniles, so you're right, they have this short gestation period, it's only 2 months. When an animal that size usually takes 4 months, so they have a short gestation, and then they are born and they have about 3 or 4 months to go into hibernation. So what happens in the wild, these juveniles grow really fast, grow their teeth very fast. They have their molars like way sooner than any other animal that size, and the growth rates are off the charts. And then just about 2 months after they're born, they stop growing and they start putting fat on. So by the time they go into that first hibernation period, they still have milk teeth and they are smaller in size. And when they come out of hibernation, the milky teeth are still there, nothing really happened. They're still the same size. So they grow very fast, they kind of shut down pretty much everything when they hibernate, and then when they come out of hibernation, they finish growing. So that's why a wild Carogallius female might not have the first offspring until it is 2 or 3 years old, because it just takes these chunks of time to finish growing and getting ready, because hibernation is kind of like, you know, they have to get fat to hibernate. So that's an interesting aspect to it. The growth rates of these animals show some adjustment to these extreme conditions. It's very fast and then slow down and fast.
Yeah.
Very cool.
All right. Well, thank you.
No.
Folks, if you have any other questions, you can email Marina,
Yeah.
and I hope that you'll all be back out to the Lemur Center if you're not already out here every day anyway, to visit with us one day soon, and we'll introduce you to some fat-tailed dwarf lemurs and get you close questions.
I don't know, they were not,
Because-
they were not.
Going out on your tour today?
No, you were not yesterday. They're, I don't know what they're doing, even at 1 o'clock or 10:30. They're hiding, obviously, or hibernating.
I don't know.
Very elusive.
I haven't been watching video clips either.
Well, you get on that and solve the problem, okay?
All right, we'll write a grant for that. But thanks, everybody. Hope you enjoyed the evening.
You were hot.
No, you were.
I was hot. I was